There are several different types of sensors. Right now we'll talk about some simple sensors. And a lot of simple sensors we'll call resistive sensors. What they do is they change resistance. So they act like resistors, okay? But they are resistors whose resistance changes according to some environmental effect. So you can see on the left side of the slide, I got pictures of three different resistors, or rather sensors, which act as resistors. And actually, you should have some of these in your kit. That first one, the one all the way on the left, that's a photoresistor. So its resistance changes according to the brightness, okay, in the room. The next one is a thermistor. So its resistance changes according to the temperature. And the next one is a flex resistor. And it bends, and its resistance changes according to how much it's bent. If it's bent a lot, it has a different resistance than if it's straight. So these are all three sensors that sense things about the environment, and the way they transmit information is by changing a resistance. So remember that our microcontroller, it doesn't sense resistance directly, it senses voltage. So we've got to make this, put a circuit around this thing, put this thing inside a circuit. And in that circuit, there has to be a voltage which changes when the resistance of this sensor changes. So that circuit is what I'm showing there. You can see the circuit up there in the top middle, and the circuit has got, it's basically a voltage divider. So at the bottom, it's got a resistor going to ground. At the top, it has this blue box, right? This blue box is going to be a sensor, one of these resistive sensors. So it could be a photoresistor, it could be a thermistor, it could be a flex resistor, it could be any of those. As long as they basically act as resistors up there. And the resistance changes according to the environmental effect that you want to observe. Now, you'll remember several lectures ago, I talked about a voltage divider. Actually, when I was talking about potentiometers, I showed a voltage divider, and that circuit is exactly a voltage divider. Okay, it's a voltage divider. If you remember potentiometer, right? It's got two terminals on the top and the bottom, and then it's got this middle terminal between two resistors. And these resistors, the ratio of their resistances can change in a potentiometer. So similar things happening here. The bottom resistor is just going to be constant, okay? But the top resistor is this sensor, and that changes according to the brightness, let's say, if it's a photoresistor, or the temperature if it's a thermistor. And so you see between the two resistors, you've got that point there that we're observing that's connected to, say, an Arduino pin. We're going to observe the voltage at that point. And that voltage will go up and down according to the resistance on that resistor. So as the resistance changes on that resistor, the voltage will go up and down, and we can detect that. We'll have to take that pin, take that observation voltage, and wire that into an analog pin, one of the analog pins, A0 through A5, let's say. And then we'll have to call analog read to read the voltage. And based on the voltage value that we get, we can tell how bright it is or how hot it is or something like that. So that's the idea. So that's the circuit that we're going to try to build around this resistive sensor to be able to read it properly. So you're connecting the sensor in a voltage divider, which is that circuit there. And the sensor itself, since it's a resistive sensor, it is the top resistor in this voltage. Or you can make it the bottom resistor too. It doesn't actually matter. As the resistance changes, the voltage changes according to Ohm's law. So here's an example. You might have a photoresistor. So you can see that's a voltage divider. The bottom resistor I've made 10 kilo ohms, and the top resistor I have made a photoresistor. That's the symbol for a photoresistor. It's basically a resistor with a circle around it, some arrows coming in because it's detecting light. And so it's a voltage divider. And let's say that this voltage divider, this photoresistor, its resistance changes within a range depending on the brightness. So as brightness increases, the resistance of the photoresistor decreases. That's generally how they work. So I'm making up some numbers here, but let's say let's say its resistance is 10 kilo ohms at a certain level of brightness, okay? So if it's 10 kilo ohms, then that means if we look at our voltage divider, we've got a 10 kilo ohm resistor on the top and a 10 kilo ohm resistance on the bottom, which means that the voltages will be divided in half. So since you got 5 volts going from top to bottom, 5 volts in the top, 0 on the bottom, that middle point that we're measuring will be 2.5 volts because the resistors are even. So if it's at 10 kilo ohms, if the photoresistor has 10 kilo ohms resistance, then you'll get 2.5 volts. But let's say the brightness changes, right? Let's say it gets more bright. Then the resistance goes down. So now the resistance of the photoresistor is only 5 kilo ohms. Now when that happens, you got a smaller resistor on top and still got the big 10 kilo ohm resistor on the bottom, right? So now what happens is, since there's less resistance on top, there's going to be less voltage, what's called voltage drop, voltage difference across the top resistor. So now the resistance that the voltage that we measure in between those two resistors is going to be higher, 3.3 volts. Right? Because the voltage is disproportionately across the bottom resistor since it's bigger relative to the top. So the point there is that as the outside environment changes, so in this case if it's a photoresistor, the brightness changes, the resistance changes in this circuit, and as the resistance changes, the voltage changes on that pin that we're measuring. And that pin, that's going into one of the analog inputs of the Arduino, and we can measure that with an analog read. So by calling analog read, we can see the voltage value, and we can detect the change, and we can make some code that, say, does something, activates some device when the light level goes above a certain threshold. If the voltage that we measure is higher than X, then we can do something. So we can respond, we can write code that reacts to the environment. Okay, so those are resistive sensors, the ones I just described. But then there are some other sensors that are a little bit more complicated, but actually easier to use from our perspective. Voltage controlling sensors. So the first sensors we looked at, they're resistive. When the environment changes, the resistance of the sensor changes. In these devices, they don't output resistance. They don't have a resistance. They do have resistance, but that's not what you're measuring. Instead, they have a pin which outputs a certain voltage directly. And this is good for us because our Arduino, it directly senses voltage, right? So these type of sensors, these voltage controlling sensors, they output voltage directly. And so that's even easier for us. So we can just take their voltage output and run it straight into one of the analog inputs of the Arduino and measure its voltage. Now, give you an example of this sensor, of one of these sensors, a PIR motion sensor. PIR standing for passive infrared motion sensor. So that's what I have over there. And in the left, you see that passive infrared motion sensor. And you've probably seen these things like this. This is what you would have, like we have in this room actually, and in the room in my office. Motion sensor, so when you come in the room, the lights go on, something like that. So they're using PIR motion sensors. So PIR motion sensor has 3 leads. 3 wires, 3 terminals, whatever you call them. One is connected to power, one is connected to ground, and one is the signal that you're interested in, the voltage that you're interested in. So if we look at our motion sensor block over there, it's got 1 pin on the top, 1 pin on the bottom, and 1 pin on the right side. So the pin on the bottom, that's wired straight to ground. The pin on the right, that's wired straight to power. Okay. The pin on the top is the one that you can see, if you follow the pin on the top, that goes to the left, which is presumably going to our Arduino, right? Some analog input of the Arduino. So the pin on the top is the one of interest, the signal of interest, right? And that pin is going to have a voltage assigned by the motion sensor. And the way this motion sensor works is if, actually this particular motion sensor, what it does is it pulls a signal low when motion is detected. So when it senses motion, it sets that voltage on top to 0 volts. Okay? So that's what's going to happen. Now when it doesn't sense motion, it doesn't do anything to that wire on top, right? So that wire, the voltage on that wire would be floating. So that's why we have that 10 kilo ohm resistor to power. Because if there's no motion, then one thing that we never want on an input to our circuit is a floating voltage, a voltage that we can't tell if it's high or low, right? We don't want a floating voltage. So we want to make sure that if there's no motion, even though the motion sensor isn't assigning a value to this pin, this wire gets some value, right? And the value that it gets in this case should be a 1, should be a high voltage, right? Because the low is what happens when there's motion. So we want high to be associated with no motion. So when there's no motion, the motion sensor doesn't do anything, but that pin is connected to power, to +5, through the 10 kilo ohm resistor. So that's why we need that 10 kilo ohm resistor connecting it to power. It's called a pull-up path. We need that pull-up path so that even though the motion sensor isn't forcing that pin to have any value, if there's no motion, it'll just go high because it's connected to power through the resistor. So this is a common type of sensor. This is one type of sensor. It's a voltage controlling sensor. They're useful. They're nice to use. They're pretty easy to make the circuit to use them. But this is just one. There are several. It's called open collector. So when you have a pin like that, you pull low and it floats when there's no motion, they call it open collector. So we have to pull it high. It needs this pull-up resistor so that when there's no motion, it goes to high. It has a known value. Okay, so there are lots of different types of sensors that are voltage controlling, and here's a couple. The first one, the one over there on the left, is a triple axis analog accelerometer. So an accelerometer basically senses acceleration in 3 dimensions, so x, y, z. It'll tell you the acceleration. So this is useful for telling your orientation, right? Because there's always the acceleration of gravity. So you can tell the orientation of your device based on what this thing reports back. If it reports, basically, and you know what gravitational pull is supposed to be, what its acceleration is. So you can measure your acceleration in each axis and tell what its orientation is. So that is a voltage controlling sensor. So it has those holes on the side of that little board. You solder pins onto those, what's called a breakaway board. And you solder those pins on there, and then you can wire those pins into the Arduino and sense the voltage on those pins. And there are several of them, but there's one that's X, one that's Y, one that's Z. Those are the signals of interest. And you can wire those into the analog input of the Arduino and tell what the acceleration is in each axis. The next one is the dual axis gyroscope. So a gyroscope actually reports angular velocity, only in 2 dimensions this time. But again, there are 2 signals in there that you can read and see what the angular velocity is. Now, both of these type of things, these are used in any kind of device that needs to sense orientation. The 2 of them are used together, actually. So, for instance, my quadcopters, they have these built into them. Accelerometers and gyroscopes are essential because it needs to know its orientation so it can stay level. So these type of devices are commonly used for that type of application. Thank you.